The Versoix Bridge, which was constructed in the 60s, is part of the Le Mans Highway in the canton of Geneva. This structure is made of two parallel bridges, each carrying 2 lanes of traffic on the Lausanne-Geneva Highway. This bridge uses 2 pre-stressed concrete girders to support a 30-centimeter thick reinforced concrete deck.
We are currently carrying out 2 types of work on the Versoix Bridge. First, the bridge requires significant renovation after 35 years of service, carrying approximately 60,000 vehicles per day. And second, an emergency lane is being added to guarantee the safety of the users. For the enlargement of the bridge, we have used a special technique that creates a new structure perfectly monolithic with the existing bridge. We have joined the new structures seamlessly to the old concrete. This, of course, creates shrinkage problems between the 2 concretes due to the large age difference.
Nous devons donc bétonner la nouvelle structure directement contre l'ancien béton, sans possibilité d'aménager de joints de clavage. Ceci pose évidemment des problèmes de retrait différentiel sur 2 bétons d'âge très différents.
To deal with this problem, we have asked the IMAC laboratory, through the Public Works and Energy Department, to install the first 2 spans of the bridge with fiber optic sensors, in order to trace the evolution of the structure deformations as a function of time. In order to measure bridge behavior, the first 2 spans of the bridge have been equipped with 13 measurement zones with 8 sensors in each. All sensors are 4 meters long. 7 of the sensors in each zone are embedded in concrete, and the 8th is mounted on the surface. The sensors look like this one. Each sensor contains a measurement fiber and a reference optical fiber. The relative displacements of these 2 points surrounding the active part of the sensor is determined by measuring the length difference between the 2 fibers. The optical signal is carried to and from the optical connector through the passive part of the sensor. This optical signal passes through a connection box and is finally connected to a central panel by an extension cable. This location is linked by a telephone line to the engineering office where remote monitoring is possible. Each zone of the structure is fitted with sensors on the extremities of its cross-section.
Il sera possible de faire la télésurveillance de l'ouvrage.
The mean curvature can be found by determining the deformation plane of each zone, and by a double integration of the mean curvatures, the horizontal and vertical displacements of the bridge can be calculated.
The sensors, commercialized by Smartec, are adapted for this type of application. They are rugged, reliable, and their installation in the structure is rapid, so as not to delay the building schedule. Installation is merely a question of attaching the sensors to the rebars before pouring the concrete. No pre-stressing of the sensors is required, since the measurement fibers are pre-strained during sensor fabrication. Thus, it is possible to measure both elongation and shortening with a sensitivity of 0.002 of a millimeter. Each sensor is connected to the closest connection box from where it can be measured during the concrete pouring and setting phases. The boxes are then connected to the central box through a fiber optic extension cable. Concrete pouring can be carried out normally. Concrete can be poured directly on top of the sensors without damaging them. The behavior of the bridge can be monitored using the SOFO reading unit. After the application of protective paint to the bridge, the external sensors and the connection boxes can be installed.